Let's see how to answer this question. A new beta blocker medication is being tested to treat high blood pressure. Subjects with high blood pressure volunteered to take part in the treatment. 110 subjects were randomly assigned to receive a placebo, and 120 received the medicine. High blood pressure disappeared in 64 of the controls and in 84 of the treatment group. Test claim that the new beta blocker medicine is effective at a significance level of alpha equals 0.05. Notice here that group 1 is the treatment group and group 2 is the placebo group, which means the first proportion P1 is going to come from treatment and P2 is going to come from placebo. So we know that the null hypothesis states that it's a statement of equality, which means the first proportion 1 is equal to proportion 2. So there's no change here. But for the second statement, which is the alternative hypothesis, we want to test the claim that the beta blocker worked, which means the proportion from the second group is greater than the proportion from the first group. So that is the proportion from the treatment group is bigger than the proportion from the placebo. So it's P1 is greater than P2. Since group 1 is the P2 right here. Since group 1 is the treatment group and group 2 is the placebo, so the treatment is bigger than the proportion from placebo. Now we need to compute the test statistic and p-value and whatnot, so we're going to head to z-estimate or t test for difference of proportions, and we're going to use the number of successes since we don't have proportions but we do have number of successes. The number of successes in sample 1, that is the number of subjects that saw improvements taking the treatment, that's 84. This is really important to determine which one is which. So we're going to start with group 1 and then we use group 2 for sample 2. And the number of subjects that took the treatment is 120. The number of successes from sample 2, that is the number of placebo takers who saw improvements or the blood pressure has disappeared, is 64, while the number of subjects that took the placebo is 110. And then alpha is 0.05, and this is, as you can see, it's a right tail test, and then we're going to compute the values. So the test statistic, I'm going to copy paste it. And the p-value, I'm going to copy the p-value and paste it here. All right. So the first question I can answer here is the correct decision is 2. As you can see here, the p-value is less than alpha, which means we're going to reject the null hypothesis. We're going to reject the null hypothesis, which means the test statistic is in the rejection region or in the critical region. You can also compare the test statistic with the critical value. Given this right tail test, you see here the critical value is less than the test statistic, which means the test statistic is absolutely in the critical region. And the correct decision here, because we are rejecting the null hypothesis, which means we do have evidence to support our claim. So I'm going to choose here, there is enough evidence to support, which is this one. There is enough evidence to support the claim that the new beta blocker medicine is effective at a significance level of 5%. So this is how you're going to answer this question. Very important to determine group 1 and group 2. And because the claim here talks about the treatment group, that's what we're going to decide to be group 1. So hopefully this helped you, and if you do have any questions, let me know.